Our next major topic is on the concept of swing, and you'll be amazed how easy it is, actually. It's not too bad at all. In fact, it's probably the most entertaining part of Java. We've been looking at command line console, system out commands so far, so let's take a look at the GUI components. We're going to build a couple programs. We're going to look at a notepad program, and I can't remember what the other ones are. I've got a couple, maybe a calculator, something like that. So this is lecture number 8, and the lecture examples that are ones that say swing. So if I go into object-oriented programming in Java, take a look at the lecture examples. I am now looking at, in a few minutes, you might want to download those swing examples, notepad over here, and then down here we have more swing examples. Actually, let's take the swing examples. I don't think I have this one on my desktop, so let me pull out swing examples, notepad here. Assignment 4. We're going to take a look at assignment 4 momentarily as well. Actually, let's take a look at it now before I get into the big old lecture, because otherwise I'm going to forget. So assignment 3, we went over, it's about collections. So it is about creating a stack and a queue for stock. Number 4, if you choose to submit it, well, hopefully you will, it's going to be, let me load this one up so we can try to see what we're working towards here. I'm going to build a notepad for you anyway, so it doesn't really matter. Let's take a look here. I'll make this a little bit bigger. If you're going for this certificate, you need to actually, if you want the certificate for the certificate people, you have to actually, it's a pass-fail, but you actually have to do the 2 assignments per section. IT students have to do all of it for their grade. But if you're just taking it for nothing, if you don't want anything out of it, you don't have to do anything really. So don't get too much pressure on. It's a no pressure course here. If you want like certificate credit for it, then you're going to need to do them. There's only the 2 assignments. So you've actually done them for the first part, so you're up to date. Actually, a lot of IT students have already finished number 3, as I've seen at the break. So now number 4, we're looking with swing. So in this lab, you're required to program with swing and file I/O. We're going to program with file I/O in the next 15 minutes, so you'll see what it looks like. It's not too bad. Actually, it's very automated. So your application will have a graphical user interface. I put together a video on this from the last time we actually built this, the last time I taught this course. I'm going to mix it up a little bit. We're not going to necessarily build this one. We're going to look at something else. Otherwise, it would be too boring. If you go into the assignments link here under course materials, this how-to video is the in-class demonstration that I did maybe about a year ago. So it's actually, I can find out. Assignment number 4, how-to video. The date on the sucker is, see if that looks familiar? 2011. So March of 2011, so it was about 2 years ago. Let me rephrase that. So yes, I've recycled the assignment. So I put that in there because it has been. You'll also see for number 3, you'll see the implementation of another from 2003 as well. In 2011. Oh, an error occurred. Please try again later. Probably my bandwidth actually right now. So. Got some bandwidth issues going on. And so next time I meet, in the next weekend, we'll go over 5 and 6. But in fact, we'll probably hit a little bit of a review of that, so because people want to work over the in between. So, okay. So let me make this a little bit bigger. Oh, that's big enough. So what do we have going on here? Simple window. The window's done in one shot. And I'll show you really quickly here. We have 2 menus. We have a file and a style menu. The style menu is going to change the fonts. Not going to be saved in the file though. Some people think that you can actually save that. It's formatted text. We're going to save regular old plain text. So you're going to get a text file. You're really creating Notepad actually. And it'll work on your, well, if you have a, in fact I did this and I lost it, so I might just make another one here and save it. If you wanted to create it for for Mac, you can just create it, compile it, stick it, link it to your desktop, and use it instead of text edit, or use it instead of text wrangler. Use that one. It's just a plain old text editor. I might, I'm half tempted to make it so like the fonts are really big and it color codes things and stuff, so you can customize it. So we have a GUI that contains several different components. It contains a JText area, a JMenu bar. I'm going to talk about Swing and AWT in a few minutes, and you'll see the differences between the J's and the no J's. A JMenu component, which is labeled file, and with a menu that contains 3 objects: open, save as, and exit. You're going to see this today, so it's a no-brainer. A JMenu component with a label style. I'm not building the style menu for you. What I'm going to show you today in all of the examples is going to build the file menu. So you'll leave with the open, the save as, and the exit, or save as, exit. Not building this style menu. There has to be some mystery to this. It's not really a mystery, but I'm not going to go as far as I did with the collections. But you'll see how easy it is. The style menu is basically going to have a text color, background color, stuff like that. So you're required to achieve the following tasks in the components. So if you click on File, Open, you should be able to open a new file window as possible. We'll see that actually. You'll see it on a Mac. It'll look different on a Windows system. You'll have the menu on a Windows system show up in the window. With the library we're going to use, it's going to show up on the Mac system window. So your user interface might look slightly different depending upon what system you're on. We're going to use a file choose class in the implementation as well. All this stuff is automated for you. And a hint on the bottom, same task in one, the window is manipulated by the file choose class. So you'll see this file choose class object. So we're going to create a chooser object and use that. So if you click the file exit, the text editor window will close and the program stops. And then you're able to change the fonts and the foreground colors and everything else about it. Submit your source code, your .java file. For those people who are concerned about submitting stuff, just take your if you've put it into Eclipse, and in my system here, I'll just show you what mine looks like. In my home directory, I've got a documents folder. Inside a documents folder, I've got, what was that? What just failed? Preview maybe just failed. Okay. Don't know what just failed. I have a documents folder. Inside of my documents folder I have a workspace folder. Here's every one of my projects. So when I put something out as a link on the website, I'm just taking and as an example compressing it, and then this is what you're uploading, the compressed file. I see so many people cutting and pasting and putting the code into Microsoft Word. Don't ask me why. Or doing other really convoluted things to it. Just zip up the project folder. I'm going to know what it is. It's an Eclipse folder. If it's not Eclipse, if it's something else, you could do this and you could use an Xcode or something. I'm going to know what it is. Just zip it up and give it to me. Don't bother cutting and pasting. If you put it into a Word file, it tells me one of two things. You copied it from somewhere off of the internet and it was in a Word file, or it's recycled from another class, or better yet, oh, it was Preview that closed, or better yet, you don't really know what you're doing and you've never used a compiler before. So Preview is going to reopen. Here we go. It did crash. Oh, no, it's back. Okay. Well, this one's back too. Alright. So let's talk about Swing, now that we know what we're working towards. Swing. Let's get into Swing a Swing. Classes from the package javax.swing. So instead of java.util is what we looked at before. We've got Swing. Defines the GUI components, objects for which the user interacts with a mouse, and keyboard and any other form of input. Some basic GUI operations. We have JLabel, JTextField, JTextBox, combo list, panel. Most of the Swing components are written completely in Java. So the library is written in Java. So there are greater flexibility, portability. Then the original GUI component was Abstract Window Toolkit. So AWT, Abstract Window Toolkit, is a separate library than Swing. AWT is the base library. So most projects that you'll create will include AWT and then you'll also include Swing. People go, why don't we just go Swing? Half of it hasn't been ported over yet. AWT is not all written in Java. It's written in some other languages, some C, some assembly language. And it's platform specific. Swing is multi-platform. It's all written in Java. Java is multi-platform. So although we'd like to think that we can create applications for all platforms with Java, we do have some problems that come into the Swing components. Excuse me, come into with the AWT, and I'll talk about those in a few minutes. So AWT components are platform dependent. So if you're going to run it on a Windows box, you compile it on a Windows box, you run it on a Windows box. If you're using AWT components. If you're going to do it on a Mac, you compile it on a Mac, you run it on a Mac. For the purposes of your testing and your compilation, you're not going to notice a difference because you're running it on the same program that you're writing it on. I mean, you're running it on the same operating system that you're writing it on. But you have to compile it on each one of the different platforms to get this right window toolkit that you're going to get for the window motif for each one of the platforms you're going to do this on. If you're using strict AWT. Some Swing components are still platform dependent. One of them in particular, the most popular, JFrame, is platform dependent. So just keep that in mind when you start using Swing, that you might have to make multiple versions of it to get the program to look correctly. AWT hasn't gone away. That's the problem. That's the platform specific set of tools. The independent stuff is the Swing. So common subclasses of many of the Swing components, well, we have component, container, J component. You know it's from Swing when there's a J in front of it. Everything with a J in front of it comes from Swing. So we have frame, and then we have JFrame. Just because we're using JFrame doesn't necessarily mean it's an extension off of frame. Frame is AWT. So we're still platform specific, or dependent, I should say, when we're using JFrame, which is why that happens that way. So look at the hierarchy, and then once we look at the hierarchy, we'll see some examples. Rather than, because it's already sort of late in our day, so rather than having to write all this stuff from scratch, I've pre-put together some examples that we'll kind of thumb through and change around, sort of like what we do with collections, actually. So in here, it's important to know the hierarchy because we build some J components, and we stick them inside of a container, and we take the container and we stick it inside of a component. So it's a hierarchy of nested things with different layouts that we're going to put together. And when you see this, you'll go, oh, now I understand how Android got put together. Because Android takes all of the components for the layouts. We have menus, we have strings, and they're all in XML. They get parsed into Java code, and they turn into Swing-ish components. And then they get applied with the abstract toolkit, but it's not an abstract window toolkit, it's an Android SDK toolkit that makes the UI. So it's very similar, actually, which kind of leads you to believe that, you know, that's a really good choice for Java in the Android application development, actually. That's how the route works, which is completely different than the iOS environment. So the component class, operations common to most GUI components that are found in the component class. Container, two important methods that originates in this class. Add, which adds components to a container. Think of them as buckets. And set layout, and so when we start seeing these layouts, those people in the Android class will see, you know, relative layout, linear layout. It's all the same stuff. That's where it comes from for the Android stuff. So I have to go through it anyway because these guys haven't had it yet. But the Android people will go, oh, that's what that is. And you'll see it from that first weekend. So it adds components to a container, and then we have set layout, which enables the program to specify the layout manager that we're going to use for the container and positions the size of the component. So the layout's going to be how are things aligned on the screen, how do things look. Let's talk about a J label or a UI label, or depends on what library we're on. J label, which actually means the same thing. The object provides text instructions or information, displays a single line of text, read only, an image, or both. Example code. When you say example code, just hold off because I'm going to show you it all put together in a few minutes. So one thing to emphasize is you do not explicitly add a GUI component to the container. The GUI component will be displayed when the container appears on the screen. So we we don't have to explicitly do it. It gets part of the container, and then the container gets displayed, and everything inside of the container goes out for the display. So to make an interactive GUI program, we need a few basic fundamental pieces. To make an interactive GUI program, we need components. The components are the buttons, the windows, the menus. We need events. In our case, we're not looking at touch events, we're looking at click events, so mouse clicked, window opened, button clicked kind of events. And then we have the event listeners. These are the interfaces, as I mentioned before. So we implement an interface that's an event listener, and then we implement the methods that are part of that interface for the on-click event as an example. And then we have event handlers, which are in the form of methods that listen for the events to be triggered and then perform some activity when the events are triggered. So it's an event-driven model that we're working with, and as most people are familiar with event-driven behavior, it's all about what the user clicks on. So the execution of the program, and our other examples, we're looking at main, and main's just starting in and doing some stuff. Here we put the environment out and we'll wait for the user to click on something and respond to events. So some GUIs are event-driven. They generate events when the user interacts. So moving the mouse, clicking the mouse, all coming from many types of defined packages, java.abstractwindowtoolkit.event, javax.swing.event. Believe it or not, the package naming are the same, but we're coming from AWT as the base level, or JavaX as the base level. Why they put an X on here and switched it, I'm not quite sure. Other than the fact that maybe they didn't want to go java.javax. So I don't know why they called it that. I didn't name it. Java AWT event. Some of the event classes in the package are the action listener, container event, focus. We'll look at these live in a few minutes. Here's the kind of the bigger picture in terms of the three parts of the event handler and the mechanism. I'm not going to go through each one of these items individually, but if you take a look up over here, we have the focus listener, item listener, key listener, mouse movement list, text listener, all these different listeners that we can put on items. We add the listener to the item. Same thing we do in Android, actually, same concept. And we capture the event when it occurs. We also have special kind of fields for text, as we see. Text field, which is great because that's what it's called in Android, a text field, a label, label text field. The labeling is actually kind of similar. The concept is very similar actually as well. Password. JPassword is going to put special characters in the field itself. Buttons, as you might expect, the button is a component for the user clicks, triggers an action. Several different types of buttons actually that are all part of the subclass of abstract button. So one of the things that only people who really take a Java class can actually kind of do and figure out is that you can take abstract button and make your own button. So your button can have different properties to it. You know, you can just basically taking abstract button, creating my new button, and then you're creating instances of my new button in your program. And my new button can have all yellow backgrounds with pictures, and I don't know what you can do with a button, but we actually have libraries for image buttons that's built from abstract button, image button, frameless buttons, I don't know, all sorts of different types of buttons. So we have toggle buttons that have on and off and true-false values to them. Checkboxes on buttons, groups of buttons, generates an item event. Radial buttons, they're all part of the button class. So we have the button, checkbox button, radial buttons. And then we have Java Swing. This is where it's coming from, JavaX Swing.jComponent abstract button. And then we have, if you imagine there's lines here that are missing because this is a PowerPoint brought up in preview actually. So we have, this goes to abstract button. We have J button, and we have toggle button, and we have J text checkbox, and then we have J radial box down here. So here's some examples of a J combo box. We're going to see all these in a few minutes. And when you click on the combo box, it brings up a list. Inside of the list, you select an item. So makes no sense to look at examples when we can do it live. So let's take a look. So what we want to do is open up the one that was called Swing Examples. So if you haven't found it yet, you can find it real quick here. Oops, I guess I'm not going to find it real quick here. I believe it's down, so no problem. Actually, hold on, let me reset. Turn the Wi-Fi off. Turn my Wi-Fi back on.
I guess it's a site problem.
Nope, we're back. It's not a site problem. It was my computer. Apparently, it lost its internet access, but it seems to be back, which is good. So if I go into the lecture examples, the one I'm pulling up right now, because you're going to want to come back to this because it has the part of the assignment solution in it, actually, that we're going to be working on. Swing examples, this one here. We also are going to want to take a look at the one up here that says swing examples with Notepad. We want to take a look at that one too. So, all right. So let me open up Xcode and see what I've got. Xcode, excuse me, Eclipse. Let me see what I have in here. I'm like, okay, what day of the week is this? Let me open up Xcode and do some Java. Let me minimize this here. Yeah, help in finance and course materials. The examples are handy to know where to get to use, only because later on, after you leave, you're going to be, where was that? Where was it located? What was that example? Swing programming. If you unzip it, create a project, drag the stuff into it. I believe I did not download the examples. I downloaded this one. This one, assignment 4. Oops, this is interesting. This is not... this is a cool one here. We're going to keep this one in a few minutes here. Java assignment number 4. Actually, we just did that one. I'm going to leave that one alone. Okay. We'll get back to here, back on track. We're going to assume we know how to bring this up into Xcode. If not, holler and I can backtrack a little bit. And take a look at a little one called Hello World. So, because we're starting in with, GUI, we have to do Hello World. So this is the GUI version, Swing version of Hello World. We'll see what's going on here. We're going to use Swing completely. And so the traditional Hello World program, what we're going to do in Swing here, we're going to import Java X Swing. We could have just done a dot and an asterisk, but instead we're going to show you which ones we're actually using, JFrame and JLabel. So, public class Hello World extends JFrame. What does that mean? We're doing immediately right off the bat, we can't write a program in using GUI without extending something. So we're going to create a new program that's really a frame. Well, what's a JFrame? Let me show you what a JFrame is. If I run the program, I see up here in the upper left hand, this is a JFrame. It's a frame. Why did I call that a window? So that's our JFrame, and our JFrame has the word Hello World written inside of it. So this is the finished product. So I'm gonna, and this was really small because it set the size at 100 by 100, which is about that big. But you can see that in a few minutes when I go through this. So our main is going to say new Hello World. Well, we're just creating a new Hello World. What's our Hello World? Well, here's our constructor. We could have put this one on the bottom. Typically, you see this done this way. We can still do it. Put it on the bottom. If we used the template, it would have put it on the bottom for us. So it's typical to see programs written like this, all in one file, because we just have one method that we're implementing. This one's going to be Hello World, and it's called Hello World, and it's saved in a file called helloworld.java, extends JFrame. Here's our constructor. This is our constructor. Same thing we've been doing all day. JLabel, my Hello World, equals new JLabel, Hello World. Now we're going to add hello world. Because we are a JFrame, we're going to add it. Our program is just the JFrame. If we were inside of something else like a window, then we can add a JFrame to the window. But we're going to see that in a few minutes, so just hang in there. This .set size, I'm going to make this one a little bit bigger because that window is kind of small. I'm going to make it 500 by 500 this time. Let's see what happens. Pack is another method that we can do on the JFrame. What does that do? It gets rid of all the garbage, reassigns the order, and it does kind of condensing of the components. If something's overlapping something else, it gets rid of it. The concept of a pipeline, graphic pipeline, and the concept of taking a bunch of objects and sticking them through. You know what the final result's going to look like, but if something is underneath something else, you're not going to see it. Pack actually kind of just removes hidden surfaces, removes everything that's not visible, kind of gets rid of a bunch of stuff, especially if you're not using it. You added a bunch of stuff, but you made a bunch of stuff, but you didn't add it to the JFrame. It's just there. So pack is commented out because we're not really doing anything here. We don't have anything to pack. And pack's kind of optional. You don't have to run pack, but it'll make your GUI run a little bit faster. It'll make your GUI load up because it does some garbage collection on you before the GUI loads. And then we have set visible to true. Make it true. If we take this line out here and I run the program, I have it running right here, so let me close it. If I come back and I run it now and I didn't set the visible to true, I have this interesting thing that happens. It went away. Actually, it still might be loaded. It is still loaded. Here's Hello World. On my Mac system, I can tell because I have a menu bar up here. It says About Hello World. It says About Hello World version 1.0. Nothing really going on here. It's just a plain old box I get. And then I get my other Finder options, and I can say Quit Hello World. So a lot of times you'll put together everything and you'll forget to make it visible. So now I'm going to set it to visible. I uncommented out that line. So now when I run it, I have a 500 by 500 screen, a little bit bigger. Now see, it's a little bit bigger this time. I didn't set the orientation for the screen. I didn't set where it was going to locate, where it's going to locate it. So it located at the 0, 0 location on my graphic output. And you see up here I have the same thing with the About box that comes by default. If you're on a Windows system, you have a different motif. I'm on a Mac system, so it's using the underlining Mac motif, giving me the underlining Mac menu up here. Yours is going to look different on a Windows system. It's going to look boxy like a Windows system. I'd run it, see what happens when you run it. Just make sure you can get Hello World to run at a bare minimum. Nothing doing much. It's just Hello World. So I'm going to shut down Hello World. We don't need Hello World now. I'm going to actually go to the calculator program. Now, let's go to the calculator program. Calculator program is a big step up from the Hello World we just looked at. Now let me just run the calculator program so you know what it looks like. Oh, that's Hello World. Probably because that was the last one in the pipeline. Let's see. Run as... Okay, hold on. Does our calculator have a main? Let me just make sure. It is, you're right. Okay, that's what I was looking for. If this ever happens to you, it's missing a main. I can't run this program, so instead I'm going to go into Swing Calculator, and Swing Calculator is my main. However, if I had labeled it Calculator Main, I probably would have remembered it. So, Swing Calculator, or main, is making an instance of the calculator. So I've written the calculator in a separate example called calculator.java. And we have a void main here, and main's making a JFrame, same JFrame as we made for Hello World, but this time it's going new calculator. Because calculator is also, if we look at calculator up here, extends JFrame. So it's all subclasses of JFrame. So we're all working on the same inheritance or in the same line. This is an extension, this is a hierarchy, just as we've been seeing before. So frame.setDefaultClose operation. So the JFrame exit on close. So when we close the little button up here, let's just run this one here. Let me show you what it looks like now. Swing calculator should load up. This should close, which it does. This is what they close on exit for the close button. Yours is going to be a red one on the right hand side if you're on the Windows machine. Frame.setVisible to true. Just like Hello World, actually. We created the frame. The frame is going to be equal to the new calculator, new instance of the calculator object. We're going to look at that in a few minutes. And we set some parameters. We could set the title here, frame title. In fact, I think the frame title is probably set in calculator. But let me run this and we can see what we're looking at. And what we're looking at is calculator on the top. So we did set it up here. We could set it up there, we could set it in here. If we click on the buttons, we actually see we have a working calculator. Actually, to a certain point it works. It just does additions and subtractions and stuff like that. And these are all buttons. And then we have the operators. So we'll take a look at the code in a few minutes. It's very simple, actually. And we also have up here, you're not going to get this again if you're on a Windows machine. You're going to have a slightly different Windows motif. So. But this is trivial, so I'm going to close, well, I'll leave swing calculator open. I'm going to rename that the main calculator, actually, so I can find it easier. Let's take a look at here at the calculator. So it's oftentimes you'll see things broken out into sets or groups. We have the basic format that we've always seen so far. What we've seen so far essentially is the methods the data members up front, the methods down below, the constructors coming first, the other member functions coming second. You can use this format. This is how this one's formatted, actually. So we have a font character set that is of type font, which is going to be bigger font, which is going to be equal to new font. It's just setting the font. And this font that it's setting it to is a plain 20 size font. You don't really need to set the font, otherwise the font would be kind of small. I think it would be set on 12. I really didn't even notice it that big, actually. Let me run this again, actually, so I can keep it up. I guess it is big. So if we wanted to make it bigger, make it 30. Maybe I'll notice it that way. So that might actually throw my GUI display off, but it should readjust. So if I made it bigger, let's see. It's bigger. So good. Actually, I like the 30 better. So. Alright, so we've got some variables here. So we did this with Android, I think, the first time we did this Android project, and we'll do it tomorrow with some more Android stuff. Because at this point, we're now venturing out into this is compatible with what we do on Android. We're just setting GUI components. So in Android, we can have a text field, my text field, and we use that data type, and we take stuff from a XML file that we're from a resource actually that we're going to explode, and we're going to assign that value from the .text from a UI text field or something, or an input text to this value here. So instead we're saying JText field instead of UI, or instead of text field. So text field is going to be text field. These guys are private. Don't let that scare you. It just means you can't manipulate it outside of this class. It's going to be used inside of the class. This class isn't going to be inherited from. So we have private data. We have a Boolean here, number, which is going to be true by default. A string, which is going to be equal, operator, which is going to be equal to equals. And then we have another private calculator operation. Well, down here on the bottom, we have operation that we're going to look at. We have a void action method, option listener, implement selection listener. Let's see. Here it is, public class calculator option. So not the best, we have a class nested inside of this class implementation. Well, if you take this out to a terminal prompt and you compile it, you're going to get a calculator operator.class that comes out of that, because we do have two classes that are inside of the same file. But to make this easier and more condensed, I nested them into one. So, but this is not part of it. It's an outside class with an opening and closing, but it's actually inside of this class in its declaration. So it's a class that's being used by this class, obviously. Alright, and that's where this new instance of this new object is being created, which is going to be inside it. We could have very well brought it outside. We didn't have to leave it inside. This is our constructor, public calculator. Public calculator is going to say the text field is going to be equal to the new J text field. And the number is going to be 0, and it's going to be 12 characters long. So, what is the text field? I'd say, take a wild guess and say it's probably right here. That's the text field. We're going to put the number 0 in it. Make it 12. What the 12 is the measurement. 12 numbers. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Well, I don't know. Close enough. It's going to be, put it back on 0 here. Alright, so then we're going to set the horizontal alignment here. We're going to say that the JTextField.right. So it's horizontally aligned here, which is why we have the 0 showing up on the right-hand side. And then we're going to use this big font. So what we've done here is set this big font as a font. So it's a data type font. And it's public final because it's not going to change. A private final because it's not going to change. We made it like a constant number. It's like defining pi and then using pi throughout your formulas. It's not going to change. It's always going to be 30. So these guys are in 30 and the text field is in 35. So action listener, number listener is equal to new number listener. And you're going number listener. Number listener. So we put an action listener, number listener. So we must have a class that's going to be of using some method or some class implementation. This is the object type here, number listener. So if I look through the code here, I'm going to say we have operator listener class, and then we have a number listener class. So I have yet 2 more classes that are embedded inside of this class in here, which is okay to do. It's going to use this. So let's take a look at the number listener class. Class number listener implements action listener. This one up here that says operator listener implements action listener. This is why we know about interfaces, because we're implementing listeners here. What does that mean? We're going to have the same operations. We can look in here and say, well, what are these operations that we're going to have? Well, it's going to be action performed. Action performed. So it's kind of like the action activity. So if we go back to Android for a second, we go like, it says this class implements. In fact, here, let me just. Let me just do this for a second here. New project. Let's just go here. Other. I want to create a Hello World Android, so I have something to look at here. New other. Android application project next. I just want to compare it to something here. I'm going to call this Hello Android. You don't have to do this. I'm just doing this so I can show you something visually. Helps me demonstrate what I'm trying to talk about. I'm creating an activity-based default Hello World. If you were here for the first interactive session, we actually did this for Android. Don't need to do it again. If you still have it, you can open it up, take a look at it. What I'm doing is I'm looking at mainActivity.java. MainActivity.java here, as soon as all these red things go away, is in here. And mainActivity.java, I've opened it up, extends activity. Because it extends activity, activity has an interface in it. So if I accidentally take this out as an example, see where it says override? You can instantly say that that is overriding either something that's abstract or it's an interface. Do we really care what it is? Actually, we can leave this one here. Don't really care what it is because it needs to be implemented. So if I put my mouse, here we go. It should complain about the onCreate as soon as it catches up and figures out what's going on. If we're extending activity, an activity has an interface in it that has an onCreate method that must be implemented, then, well, let's see if I save it, it'll give me a message maybe. I need to have an onCreate method. If I don't have an onCreate method, my computer though is running a bit slow. onCreate options menu. Here, we'll just take this one out. How can it be a main activity class if there's no onCreate? So we're supposed to get an error message here, although it never behaves when it's supposed to. Well, if I run it, it'll finally catch it. Or is it actually going to run without an onCreate? Well, in the old days, it never used to run without an onCreate. How does it know it's going to create? How's it going to run without an onCreate method? So, long story short, activity is a class that we're extending from. In the interface of activity, there's an onCreate method that you have to implement that method. If you don't implement it, it doesn't work. So long story short, this is actually loading. Probably just come out with a fatal exception method instead of actually, I'm not going to run it. It's going to come out with a fatal something because you need an onCreate method. So here we're not abstracting, we're not inheriting from the class. Instead, we're just going to put the interface in here. So it implements action listener. Action listener has one that says action performed. If I come down here to this action listener, I have another action performed. And the action performed method is following the same prototype that is inside of the interface action performed. So how do you get that? You don't know. You have to guess, or you have to go through documentation and know that there's an action performed in there. Both of these are going to look pretty similar. They're going to be implementing what's going to happen when an action is performed for a number listener, and also then for a operator listener. So the operator listener is actually more complicated, so I'll start with that one first. There's the action perform method, the only method that's in here. Instead, what we're going to have is we're going to say, if it's a number, run action. Where's action? Well, action is going to be out here somewhere. We're going to have another action method that's up here, probably convoluted. It's probably the most poorly documented code around, but run action, we'll find it eventually. And text field.set text to 0. Same thing we get in Android, actually, it's the same kind of concept. Else, number is equal to true, it's the Boolean value for the number to true. And then a string display string is going to be equal to the text field.getText. If equals operator is equal to equals, this is for the operator listener, by the way. Then option.set total to display total if we have an equals. Else equals operator is equal to plus, equals operator is equal to minus, equals operator, the operator, this is going to keep track of the operator that was selected. Asterisk or division. And then text field set text to the something, put a space in there, plus the operator get total. So operator dot get total string after we perform the operation. And then equals operation is equal to e dot get action perform action command, which is going to be another method call. So then we have the same kind of similar text that goes on here. This one's a little bit easier. It's just digits. When we type in the digits, they show up in the text field. So if it's a number, on the number listener, text field dot set text to the digit, number is equal to true. Else text field dot set text to text field dot get text plus the digit. Add a number to it. So when I go in here and I type, where'd it go? So 1. If it's a number again, 2. So this is where it's saying text field dot get text plus the digit. So 3 is going to show up behind it, which is how that functionality is working. So, and if you kind of play around with the plus, it's not going to do anything. It's going to go, well, what is the plus? And it's going to run a method. Plus what? Well, it's going to wait for the next input that's going to show up. So in here, if I go plus 2, I see 2 shows up because it's a number digit. So it's working out the logic of what's in the text field, what operator. So if the operator was there and operator is performing, then take the value that's in the text field, which is 2, and then when I hit equals, it's going to be 125. I don't know what I put in. 1, 2, 3 plus 2 is 125. So mathematically, it actually works. So, and I believe the calculator actually is performing, most likely. But let's see what else is going on here. we're primarily not really interested in the math part of this, primarily interested in the use of the components and the GUI swing thing. So we're making a calculator op new instance is equal to new calculator op. We make a new instance of that object. So those were the variables that we've contained. We've created as data members. Now in our constructor, we set the font. We have an action listener. Actually, we got this far already. Number listener is equal to new number listener. So we're going to make a new instance of that method of that class that we created. We're going to set the button order. Here's the button order. What is the button order? It's going to be this button order. We have a button that we're going to create. JPanel button panel. We're going to create the buttons, JButton, stick them in the JPanel. Call it our button panel. So JPanel is the data type. Button panel is what we're calling it. It's just going to be a panel. So we can stick anything we want in a panel. So panel, this is a panel. That's a panel up here. So we can put the panel in the layout. This is probably a linear layout, but let me take a look further on. Oh, it's a grid layout. I'm sorry. It's a grid layout. So for those people who were here for the Android class last weekend, grid layout is a grid layout is a grid layout. It's the same grid layout we saw last weekend. So but don't worry about it if you're haven't been there. So JPanel, excuse me, button panel, which is the button panel we just created, dot set layout, and that was going to be equal to a new grid layout, 4x4x4. So this is 4x4x4. 1, 2, 3. Well, it's 4 by. It's square looking, so as much as possible. Which so for I is equal to 0, I is less than the button order dot length. Button order is 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So take that dot length. That's going to be our string that we're going to use for the keep track of the buttons. I++. This is a very similar kind of a loop we see all the time. Although we're missing our indentation in this example, so it's kind of hard to see that this is inside of a loop. It is. String key is equal to button order dot substring I plus 1. So we're starting with this substring, and we're going from 0 to 1. So we're getting 1. From 1 to 2, we'll get 2. So it's a kind of a crude way of going through a string. Kind of many different ways of doing it. You don't have to do it this way. Else key dot equals a space. Button panel dot add new J label, and the new J label is going to be a space. So we have a space in between each one of these guys. Otherwise the buttons themselves would be like next to each other. So we add a button 1, put a space in, add another button, put another space in, and the space is just a single nothing, so it's one character. We can actually add more to this, like put a B in there for an example and then run it. It's already running. What's going to happen? Am I going to get another instance coming up? I see the B at the end of the space. Well, it's going to mess it up. Where was the 0 before? No, we got this. So we see that this is the space in here. But it's being zeroed out by the other. So we'll just leave it alone. Leave it as a space. So the else. So we're putting a space in at the end. We can actually, it's also inserting a space, but it's not. It's looking for the key to be equal to a space, which means we're at the end. There's a space at the end of this one here, which is what that key is looking for. So once we created the keys from it, string key, if it equals the space we hit the end, it's kind of like putting a null character at the end. No, it's not actually. It's actually checking for the end, and it's putting a B at the end.
So not increase the space. You didn't want to. What if it drives the space between the numbers?
There is a space between those numbers, though. Oh, in here, this is going to cause empty buttons. This here should cause. Let's see. You'll see what happens right now. Should cause empty buttons, I suspect. But let's see. But we might have a check to see and skip it. If there's a check in there to, oops, not hello Android, wait a minute. Oh no, swing calculator, there we go. A space between the buttons. It's kind of a crude parsing technique. It's taking that list. Actually, we can reorder the buttons like this. And switch the list around, and the buttons are going to be ordered in the opposite list. So, or actually, we could do this too. We can have 2 number 1 buttons. Here we'll pick 3 number 1 buttons. It's just taking that list and parsing it. Yeah, the first 3 numbers are 1. But then we're going to have 1, 1, and 1. Because it's really taking the label of the button, the text on the button, and setting it to the number of the button that was pressed. Remember that iOS calculator we did that took the label? It's taking the label as the value, because now we have 3 1s that were put in here. Doesn't matter which one we click on, they're all 1s. So it's kind of crude. So I'll make this so I don't ruin my calculator here. 1, 2, 3. But you can kind of see how we're creating from the grid layout. We're putting the panels of the buttons. Actually, that was a good test here with the spaces, because you can see how the layout looks. So there was one thing I noticed when I looked at this, actually. When everything is uniform, well, it's hard to tell, but we have a section in here, and we have a section over here, we have a section up here, and we have 4. There's a grid. It's a grid layout. So the grid view, the different grids, the different components in the grid are different sizes, but we have 4. It's a 4 by 4 by 4 by 4 by 4 grid layout. So we can arrange things like this is all spaced out, and the calculator got big this way. But this didn't get affected because this is in a totally different grid anyway. So, because at this point we're just putting the numbers out there. So we'll put the numbers back, make them normal. This one's more interesting than the notepad because the notepad is just making instances of objects. This one's actually taking these objects and putting it out there. So, and the button panel, or add the label. So else J button is equal to new J button with a key. That's how we're getting those keys out here, because those are the keys parsed from starting location to 1 plus 1. And here's the biggest thing here, which is not that big of a thing. Button.add action listener. We're adding an action listener. The listener we're adding is a number listener. So we have 2 listeners defined. The 2 listeners are both implementing action listener. So we have operator listener implements action listener, and number listener that implements action listener. They're both action listeners, so when we add an action listener, add action listener, we're taking and we're adding it, we're sending it which one we want to add to it, which is the method that takes the listener that we've created and puts it on the button. So when the button's checked, or the button is selected, action is performed on the button. In fact, you can actually go down to button click, button touch, on the Android actually. Run this listener, number listener. And then set the font, so button.set font to bigger font. We can change the font color actually if we wanted to. We can change the font size. And then here's the last but not least, button panel.add button. So this loop is going to go through that entire string. Add the button to the link, then add the button to the panel at the end. So the panel, if we leave out this code here, no buttons are going to show up. So if we run it with this, because the button panel doesn't have any buttons on it. So here's how tricky it is. Although this is working quite fine, but this panel over here, the part of the grid we're trying to populate out, we forgot to add it. So most likely if you don't see something showing up, make it look for the add. So button panel here, add it. And the button panel is coming up from the button panel that we originally defined, which is button panel here, JPanel button panel equal new panel, button panel dot set layout to a grid. So we're adding it to the button panel. We're adding the button individually. Then we have an action listener for the operator listener is going to be equal to a new operator listener. So we made a new instance of this object the same way as we made this one here. We could have put them both up here at the top. We didn't have to put them down here like this, but we kind of separated them out because this is all about the numbers. This is all about the operators. Taking the same code and we're going through a string. So we have operator string where we have a plus, a minus, and a, a asterisk, a divide, and equals, a C for clear. So we have all this string, and then we have the same grid as before. We're going to create and use the same thing, and you'll notice that here we have another loop. So when we're using the same concept before, we're doing button.add action listener, operator listener. So the operator listener is going to look for an action that's performed on the button. In this case, it's going to be a click event that we're looking for. And then here's an interesting thing. So we have a jpanel pan equals new jpanel. So this set the layout now, we're going to equal to a new border layout, 4x4. So what we've done, in fact, I can probably, probably better document this sucker here. This is where we added the operators. And here we added the numbers, added number buttons. This code could use a lot more documentation. Here we just set the properties. This is the actual calculator class. So now you can tell what a lack of documentation can do to the readability of this. So, what are we going to do down here? Well, we're going to set the panel. So this is frame properties for calculator panel. Calculator panel. And here's where that title's being set. This .set title calculator. Set size a resizable false. It means I can't make it. I can't change the property for it. Yeah, I can't make it. If I take this out, then I could do this, and this is not quite desirable because it's going to throw off our layout. Does it really throw our layout out? No, I actually kind of like this better. Makes the calculator bigger. Kind of a big calculator, smaller. Oh, that one looks pretty good like that too. Huh?
Touch event.
Touch event, yeah. Actually, this would be like the Android version of it. So, right. We'll take it off. We'll make it sizable. Yeah.
Where are we setting? Which grid we placed where in the?
When we put it together. In the, let's take a look here, calculator operators. No, it's actually done for us already at the top here.
I think we're putting it at the bottom.
Oh, let me find out here real quick. The bottom of this method is what you're saying?
No.
Action, that's going to be the action performed. Add the text field, the border layout. So we're adding the panel, the button panel. Here we are. Okay, so we're running a jpanel application. So the jpanel pan, we're creating the panel. We're setting the title of the panel. We're setting the sizable. We're setting the pack. So we are running pack on it. Set the context pane to pan. Excuse me. Pan is the panel. But before we do that, we're going to add the other components to it. We're adding the text field, we're adding the button panel, and we're adding the panel, which is going to be all three of the components. Panels coming up from here. So this could have been operator panel. So that's what I was saying. That's my complaint about this example. It's not the most labeled correctly or documented correctly. To kind of put the pieces together, it's kind of a mystery where all these parts are. So one of the things I could do is actually better document this. So I'm sort of doing it while I'm talking to you. So we're going to set the layout, border layout. For the panel, it's going to be the border layout. The buttons are in a grid. So we have the button 4x4 grid on the buttons and the grid view. The grid view is inside of that button panel. That button panel is being stuck inside of this J panel. That J panel is inside of the frame because we've set the content pane to pane. This is a method that's going to set the J frame that we're using. The content pane to pan, which is the panel. So if we go back to that boring PowerPoint and we look at the different contexts, we have a container that fits inside. So I think it's still up actually. If we look at the hierarchy here, we're really working with this from a component. So let me go back up one more slide here. We are really working with, I don't know if it's even in here, but it might be. Let's see. Here it is. J components that are inside of the container, the panel, which is inside of the component, which is going to be the frame from the component level. So we have that hierarchy going on with all of the different options that are available. And we're using all of them, which is what you're going to use in most of your Swing applications. It's going to be a compilation of all these different parts. So if I forget, as an example, to leave the button panel out, and I don't add it to the panel, I'm going to have the whole thing built, but the buttons aren't going to show. So if I run it this way, I have no buttons. Same problem was before because, and I use the buttons as an example because it's the same thing before. If I don't add it to the panel, well, what panel is this? This is the button JPanel panel for the buttons for the panel. For the add operators, well, actually, this is the different panel. So which one did I comment out? Oh, I commented out the other panel, the button panel. So that one would have been this panel here. So this is for the operators. That was for the buttons. So now I can see this is where the buttons are being added for the operators. So now I have the whole thing assembled, but I don't have any operators because I've left out that sub panel. So I've got this panel up here as well. So if I put this panel back, and I can see, well, what is this panel here? This is going to be the text field that shows up at the top of the screen. And this one here is going to be the text entry. So now I have a calculator that doesn't have a top entry. And it looks like I forgot to comment out the panel for something else as well. But so I can see that I've got all those components, those panels that I'm loading up inside of the container. So let me put this back. So let's see, I should have everything uncommented at this point. Let me make sure I've got my calculator back. Oh, yes I do. Okay, good. Everything's back. Alright. So now I have action. Remember that method? So this is the action method implementation. It's being called. I've learned how to spell implementation today. What did we call it? Actually, what we can easily do here is just go like this, highlight action, and then it highlights it everywhere else. Oh, I know I saw it up, and I said, don't worry about that. We're going to see it in a few minutes. We called action from somewhere. I don't remember where it was. No, that's the method implementation. Oh, here it is here. We called it inside of the action listeners. In fact, we have this action here that's implemented here that's being called inside of both, no, just one method. It's being called inside of the action listener for the operator. It's going to be the action. What's the action? The numbers are going to be equal to true. The text field is going to be set to 0. Equals operator is going to be set to equals. And then the operator.set total is going to be equal to 0. So if number, and set the essential action method that's going to be implemented, that's going to run. So we're running a method here that's inside of the implementation, which is kind of interesting because it's in the same scope of, this is a class, but it's inside of the same definition that's going on for the operator, for the calculator. So the nesting here is not quite the best in terms of clarity. So text field is going to be equal to 0, else numbers equal to true, string display text is going to be equal to text field.getText. So the equals operator dot equals, and this is an interesting way because you can test the dot equals on here, which is a built-in method. If it equals this, if it equals that, that works. Equal operator, let's see where this is coming from, is equal to 0, which is originally set to equals by default, which is going to be set in action. Action is going to set it, it basically sets it back. This should really be like a reset button for the text, for the operator actually. So the naming of these methods aren't quite the best either. So. I'm sorry? Okay. Alright, so getting towards the end of this down here, the class number listener, we actually kind of went through that a few minutes ago. Now this is the one that's going to do the work here, where we're going to essentially convert to number, the total, plus equals something to add. So we're going to take and perform on the string that we're receiving. The string that we're receiving is going to be the parsed information from the text that appears in the text field. So the edit text or text field dot text is going to come out and say, well, for the calculator operation, total is going to be equal to 0. What we really want to do is return some value that we're going to stick out there. And we're calling this method just to do the calculation. So string get total string is going to return the total. This is a makeshift way of converting the total to a string. So if we run the calculator operation dot get total string, it's going to return the value that was returned plus the plus an empty space. So it's going to take. Remember what I did with the system out, and I put the string plus a number and converted the whole thing for me. That's what this is doing. So we had the set total. We have the add operation, the subtract operation, multiply, and divide. And then we have to convert to number. So we're going to take the string as a parameter, take the string, go integer.parseInt. I believe we did parseInt part double for, we did the temperature conversion program in the beginning. Was that this class?
Yeah.
Yeah, okay, good. Assignment number 1, temperature conversion. So we did. I'm like, is that this class? Yeah, I'm sure it is. If you did that one, you used this already, actually. You used the parseInt, parse floats, or something of that. Parse something or other that to convert your strings to numbers so that we can do it. This is the same stuff that you were doing before. The convert to numbers, convert to number here. It's a private method inside. So one of the biggest things here, that's the end of the code actually, so one of the biggest things here is all of the classes that are implemented in here that are all nested inside of other classes, or they're nested inside, and they're all private. I mean, not all of them are private, but this one here is private. And so for abstraction purposes, we could break it all out into separate files, or we could leave it all together. In this particular case, I think it's a lot simpler to put it all together in terms of that. But by following some basic mathematical operations and by parsing a string, we've created some buttons. Not bad. Questions about the calculator? Alright, let's close the calculator up. I'll save it as is. So that one was running too. So we have the, I'm going to get rid of this one here while I'm at it. Let's take another quick look here. I'm going to delete the project too. We still have a few more minutes here. We're going to get through it. So let's see. Tic-tac-toe. Another button. This one's a lot easier. So I started with the big one. Now I'm going to go to the little one. Now I'm going to go to an extremely easy one. So we're going to start with big and come down. So now that you're all afraid of swing, let's take a look at this one. Tic-tac-toe is about as easy as you can get. Let's run tic-tac-toe so you see what tic-tac-toe does. Tic-tac-toe, I believe, is all in one file, and it runs like this. Looks to me like a tic-tac-toe game. You press, you got an X. I know, you guys are going to find this common theme. I do tic-tac-toe and calculator, every language. 0x 0, 0 wins. I know, this one doesn't have that problem because it's not selectable. And this one doesn't. That's because I took the button, made it not selectable.
Yeah.
Well, you can do that. Actually, that's the trick you can do for the iPhone one. Make it not selectable. And for the, which is the other one? I know I did tic-tac-toe on 3 different ones. I did Android tic-tac-toe.
Yeah.
But that one was done programmatically without using the buttons. I have another version of tic-tac-toe that's using the buttons. But that one was for something else. This is a simple, easier than the calculator. Tic-tac-toe implements the action listener. The whole game, the whole J-frame is going to be in a window. The window is going to be called tic-tac-toe. The entire class, tic-tac-toe, is using the interface action listener. So everything in the class is going to, we don't have to create separate action listeners because we're not looking for numbers versus buttons for operators. So if we run it, we see at the top, I'm going to leave it running for 1 minute here so we can kind of see. Tic-tac-toe gets printed on the top up here. And then we get a bunch of buttons. So we have a JPanel window. We're calling it window. Equal to new JPanel tic-tac-toe is the title. It's the constructor for the JPanel, takes the title as a parameter. And then we've got JPanel. This is probably the slowest way of doing it, but there's 9 of these buttons. It's a 3x3 grid. So we have button 1, button 2, button 3, button 4, button 5. I could put a space down here. Let's do it that way. All those buttons. New J button, nothing in the button. The button's empty, so it comes up with here, empty. We could put a question mark in the button if we wanted to, but then let's not play with it at this point. We all want to go home eventually, so or go to the St. Patrick's Day party. So let's just assume we could put something else in the button if we wanted to initialize it with a question mark or something. String letter 0, empty. So we're going to start out with the letter. What do we got? We have X's and O's. So when we're going to start out either arbitrarily, we're going to count up how many we've got. Do we have 3 X's in a row, 3 Y's in a row? The game goes horizontal, vertical. It does all 3 actually, horizontal, vertical, and diagonal. Integer count is equal to 0, meaning we have 0 X's. We put an X in, and we put another one next to it. So if it tests horizontal, we have 2. When we get to 3, somebody won. We have a Boolean for a winner. Winner's false. No winner yet. So this is the tic-tac-toe. Here's the constructor for the tic-tac-toe. Public tic-tac-toe. As I say, this is the easiest one. Easier one. Create the window. So the window size here is 300 by 300. Actually, believe it or not, that's the same size you get in an iPhone window, an Android window. It's about the same size of an Android. In fact, we could take this and convert it to an Android application. The whole thing. Instead of using Swing, use the Android API for it. The code's the same. It's Java. So window.setDefault close operation to exit on close, so the whole thing will go away. Do we really need to do that? If we go like this and take it out, actually it's kind of an interesting. I think by default it does close, but let's just take a look here. That might just be a Windows operation. Might just be a Mac operation. It does. Oh, see, it doesn't close it though. It's still open. It closed the window, but the application is still open.
Application is still running.
Yeah.
That's right.
So I can say, if I had one in here, I can go new. So the application's still running, so it's actually going to close the application. So exit on the application. So I'm going to put that back in because I want it to close. So then we're going to. We had that also. Yes, we have all these components in the previous example too. It's just convoluted. This one's a little easier to follow. We had all of these in the previous one too. I probably should have started with this one and worked. But if I start with this one and work difficult, then you have the impression it's going to get harder and harder and harder. It's only going to get easier. If I start with the most difficult one and work backwards, see how easy? I should have, like, you know.
Now that one can be tried.
Now you can go back and look at calculator when you're done with this one. It's all the same stuff over again. It's just, anyway. Window up here, not to be confused with window. It's not a J window, it's a J frame. These are all J frame applications. J frame is the window. So the window properties for the size, set the default closure on the window of the J frame. Set the layout to a grid. It's a grid view layout. But this is a 3x3. 3 X's and 3 columns by 3 columns. So we have spaces by 3x3 grid. Add buttons to the window. What are we going to add? Add button 1, 2, 9. All 9 buttons got added to the window. Add action listener to the buttons. All the same. So add action listener this. It's this and not an action listener. In the other one we had 2 action listeners, if you remember. One for the operators, the other one for the numbers. Number action listener, opera action listener. But this is this, which is why I wanted to use this today, because this is used a lot. It's this object. This object is implementing action listener, which means further down the code we have the button, we have the action defined, and we're going to see that probably coming up right here, action performed, which is the method we need to implement. So then we have make the window visible. If we leave this out, our entire game doesn't run. So believe it or not, this is the entire user interface. It's all the buttons with all the labels, but we don't have anything set on the labels because when we have the action listener, when the user clicks on the button, we're going to disable the button, set the label. When we set the button to disable, it can't be clicked on anymore. So set the set visible to true for the window. And then here's the action performed. This is the method that's implemented by the action listener in the interface. If we don't put this in here, we're going to get a message that, hey, would you like to implement this an implemented method or make this thing abstract? No? Okay, so implement it. Count plus plus. So we got from 0 and we went to 1, we went to 2, we went to 3. Well, we could go odd even. Actually, I thought about that. Odd numbers. If the count is odd, we know it's 0's turn. Even as a, or we can just blindly go every other. Calculate whose turn it is. If count is equal to 1, or count is equal to 3, or count is equal to 5. Odd numbers? Even numbers? Because we only have 2 people. So 1, 2, 1, 3, 2. So we know whose turn it is. I know it's kind of stupid, but some way of calculating whose turn it is. Display the X's and O's on the buttons. What are we going to do? We're going to set button1.set text to the letter. What's the letter? The letter is set to X if it's O's turn, X's turn. It's set to O if it's O's turn. I know. Convert this one. Actually, this used to be an old assignment. Convert this to images. A little bit trickier because you got to change. No, you just set the button image, but you have an image instead of a letter. So you can take and create an image button or an image. We have something that we're going to do with images. It'll show you images. You don't necessarily need the button, you just need the image, and you put the image on the button instead of the text on the button. So here it says set text. Well, we can set the image to the button to an image. The images are going to be set with pictures of X's and O's instead of X's and O's. Only problem is you can't check to see when you go to do the calculation to see if there's 3 X's in the row. I'm gonna look at. I guess you could look at the name of the image and get the image, and then say if the name of the image is x.png, then you have 1. If that's x.png, you have 2. So displays the X's and the O's on the buttons. If a.getSource, what's a.getSource coming from? Is coming from the turn. We're still in the action performed, by the way, by the event action listener. So action listener is going to call in our implementation of this interface this action performed. Action performed is going to go over and say, well, if a.source is going to be a.source is equal to button 1, a.source is equal to button 2, else button 3, button 4, button 5, set the text to the letter. The letter is going to be an X or an O depending on whose turn it is. We don't exactly know on every iteration, but we know it's going to be every other. Then we have a method here that says determine a winner. Yeah?
Set enable is actually making not a toggle.
Set enabled false. It's like saying disable it. Yeah. We take this off here. We can select the button again. So we had if you were in the iOS course, here we'll do it for button number 1. We had a little bug.
Yeah, we had it.
You could do the same thing to get rid of the bug. Was if we made this one an X and this one was an O, and we said, oh, I want this one to be an O. There we go, an O. Oh, no, change it back to an X. No, change it to an O. Change it to an X. We fixed the problem in this implementation by disabling it. It's the same thing you can do in the iOS application, just disable the button. So you can't click the button anymore, if that's the case. Alright, moving right along. Determine a winner. Woohoo! If button number 1.getText is equal to button number 2.getText, and these are ampersand symbols, by the way, they look funny on the screen, and button number 2.getText is equal to button number 3.getText, and button number 1.text not equal to empty, which means it's all filled in, and we have a winner. Win is true. This is the horizontal, the vertical, the diagonal. So, and in here, this is part of the button. For every time we press a button, it's performed in the action performed method. So the action performed method is going, we've selected an item. So we have to select the last item on the last item selection. If they're all filled, none of them are blank, then something over here is going to happen. Because over here it says, at the end, the last one, we're checking to see, make sure that none of them are blank, we got a winner. So if all of them are filled in, which means we're going to get a tie at the end. So it actually does determine a tie. So this is the horizontal wins, the vertical wins, the diagonal wins. And then lo and behold, on the bottom it says show a dialogue if someone wins the game, or if it's a tie, or the game is a tie. Where do we have the tie? False, false, false. If all the buttons are filled in, it should be a tie, and nobody's won. True, 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 true.
It can be true or false
On the end, it says win is equal to false, so it's going to be true or false. So if win is equal to true, then J option panel dot show message dialog null letter. This is going to be X or O plus wins. Else, if the count is equal to the count. This is how we're doing it. If the count is equal to 9, and the win is still equal to false, nobody's won yet. Then J option panel dot show. And we're doing it on the J option panel. We're just going to do show message dialog. Brings up a little dialog box. We could put in, I believe this is the title for the dialog box. Let me actually run the dialog box and we'll see if it should be empty. I just want the dialog box to show. Message. And this is the default image because we didn't set an image for the dialog box. But it's the show message dialog, which is going to show message. So, what is the null value? Maybe, I don't know. You have to look at the documentation to see what the dialog box parameters are going to specify. Each one of them is going to be a little bit different. But,
you can try to change them and see if messages.
Well, I believe it's going to take a number. Like 2? No. Actually, here, how we can do it. We can go like this. Oops. Let's do it this way. I can always go show. I'm waiting for the little pop-up box. Show message. Oh, it's not going to be happy with it. Maybe I have to go here. E dot. Oh, no, it's trying. There we go.
Small.
Show message component. Parent component. If we had subcomponents. If we had this, we don't have any parent. We are the parent. So we're not going to have, it's going to be null. We don't have a parent. It's going to be if we had a...
Parent.
Yeah, but we are the frame. I believe we are the frame.
That's the parent for the parent.
Yeah, so we don't have to specify it because we're at the highest level. We don't have any sub-windows in here. We could show it in a different parent if we wanted to bring it up, so we don't have to worry about that. So I'll just...
There are other methods actually which accept string and integer other than these two parameters.
Well, one of them depends on the type of dialogue we're going to show here. Let me see. Let's just go here, show. Confirm dialogue. They're all going to take the component as the beginning parent. Let's put in here, input dialogue, object string, message, enter something. Let's just see, I'm just going to play around with this for a second here. This is only going to happen if somebody wins. So let's just do it this way. I'll just make somebody win. Tic-tac-toe is easy enough. This is going to give me another dialogue that's going to have an input field that's going to say enter something with an OK button. So somebody has to win. So X just won. Enter something. Hello. And then go OK. So the dialogue, there's different types of dialogues that are all built in for us. This is just an example of the dialogue. So I don't know what those parameters are. You have to basically look it up and you'll see what they are. So don't want to save this because we don't need that one. So tic-tac-toe, you want to see something even easier? Okay, so now you got your confidence level up. Notepad.
Actually, the third parameter in that show message dialog, that's the title.
Oh yeah? Is Notepad easier? In concept, it actually isn't so bad. Let's just take a look at Notepad though, because we have some minutes here. So calculator, hello world, swing. This is the last one of this set. I have another Notepad. I'm not going to rush and get all done with this today. Instead, we'll finish this tomorrow morning. Now let me just run Notepad so you can kind of see what's going on here. There's a couple of different versions of Notepad. This is the easier of the two. Java Notepad tutorial. And so you see this is the window where I'm going to type something in. This is a test. The font's kind of small though. We can modify this, make the font bigger. And up here we have a file menu. I'm going to go save. And it's going to bring up a dialog. It's a file chooser. Like it's actually one instance of one method that we're creating. Oh, excuse me, of one object that we're creating. And here I'm going to call it a test. And I'll put it on the desktop. Maybe can I select the desktop down here? Yeah. Oh, is it?
You're on desktop.
I'm on the desktop. Here we go. Desktop. Very good. I'm going to call it test dot, I don't know, something. So it actually does work if I come out here. I should have a file out here on the desktop. No, I don't have a file out here on my desktop. Interesting. Maybe it had something to do with the type of file that I saved it as. Let's just do something different here. Let's go test.txt. And maybe it was a bad file name. Hacker desktop. Ah, I didn't. It's actually in the other folder.
Yeah.
So now it should appear somewhere on my desktop here. Here it is. The other one is actually in bhacker. So if I go to home directory, which is bhacker, I should see it. Here it is. Test.something. I dragged it to the desktop here. So it didn't have anything to do with the name. If I open this up in preview, it's not going to open it up. It doesn't recognize the file type. If I double click on it, it's going to say there's no application for this. Open with an other. This is open it up in a text view or something. Here, I'll open it up in Text Wrangler here. It's just a text file. It should open up in a few minutes. Oops, here it is. Look at that, it's a text file. This is a test. So this is what you're doing. Actually, you're creating a functioning, our other test is going to look the same. This is what you're doing. You're creating a functioning test program. Why do we have Notepad? Oh, we have Hello World up. Let's quit this one. Another Hello World up. Let's quit that one. Okay. So the main window here is our About box you see on the Windows systems. This menu here will be a drop-down menu here on your window if you're on a Windows system. It's not going to look like this. You're not going to get this up here. This is the motif for Mac. This is what we built. Open, close, and save. This is what you get in the assignment description. So I'm going to leave this right here for a second and go back to the code so we can see how it's implemented. So just like the other one, the tic-tac-toe game, where we had class tic-tac-toe implements action listener, but then we created the JFrame inside of it. This one extends JFrame implements action listener. So all of these examples are doing a slightly different, no, not all of them, but this one's a slightly different approach here. We're extending JFrame, so we're making the whole notepad a JFrame because we're extending it. It's also a JFrame, it includes a JFrame inside of it. Implements the action listener, which means we're going to have yet an action performed method. And where's our action performed method? Right here, action performed. So the action performed method is really big. And we have main on the bottom. So we have one action performed method, and we have one notepad constructor. So the notepad constructor ends at about here. And then the action perform, we have two methods in here. Well, that's why I say it's kind of simple compared to the next one I'm going to show you tomorrow, but I'll wait until tomorrow on that one. We go down to the really easy part. This is the main program. I used to be called JavaPad. I changed it to Notepad. You can call it JavaPad. Notepad app is equal to new Notepad. App.setVisible true. Can't get any simpler than that. That's our main program. What's the constructor doing? It's setting up a text area. We need that. And then on the text area, it's showing you the scroll bars for the vertical only. We could put a horizontal in there if we wanted to, but it's just so you can go up and down. So we're going to create the menu bar. It's just another component here. So menu bar space menu bar is equal to new menu bar. So first create the menu bar, and then menu file is going to be equal to new menu, which is going to be our file menu. So menu bar. So menu bar and a menu. So just kind of we're going to go through this in a lot more detail tomorrow, but you know, maybe it'll marinate overnight. Menu item. So the menu bar has a menu, and then the menu has a menu item. The menu item shows you a little picture. Look at that. Examples, options. Shows you a little picture of what the menu items actually looks like. So, open file, save file, close. So, we're going to call it open file. We're going to put something different on the menu. It's going to be open, close, and save, I believe it says. They're all menu items. So, an open option, a save option, a close option. This is the data, not the constructor, but the data that we're setting ahead of time. So, it's very common. You'll see the data up front, just like a regular class. Here's the constructor, Notepad. So Notepad is going to set the size to 500 by 300. We did the set size in the tutorial for the what do you call it? Hello World. So set the title. So here we're going to set the title to Java Notepad tutorial. So we can call it Barb's Notepad or something, or your Notepad. So you can impress all your friends after 1 weekend of Java. You can, look, here's my Notepad program. Oh, can I have that? Actually, if you compile it, you know, you can run it on any system, you know, so it's really not that hard. Set the default close operation. This should look familiar. We're just going to set the exit on. A lot of these stuff is done for redundancy to show you that it's pretty much all the same kind of pattern. So we're going to create the components, and we're going to put the components in the panel. We're going to put the panel in the frame. Well, we don't actually have too much to put in here. We just have a text box. And that's about it. So we set the default text area font. You know, I didn't really like that 12-point font. I'm going to make my font to 30. I like the font a little bit bigger. So I set the default font in the text area. This is why we didn't have to worry about the size of the text area. Actually, we didn't set the size of the text area. It's going to fill up with the information that we put into it. So this get content panel set layout to border layout. I'm going to go through all of the layouts tomorrow because we need to finish that. I stopped halfway in the middle of that PowerPoint lecture. We got all the layouts to talk about. Because then layouts and grids will make more sense in terms of how you're using the components. But get the content panel, add text area. Text area is the only thing we're adding as a component because everything else is run by the menu. We just have one program that comes up that has a big old text area in it. So that's why I say this is simpler than the buttons. We had like 9 by 9, a 3 by 3 grid of buttons we had to stick in there. We just put one text box in the frame. And we have a menu. So people freak out because they see the menu. They go, oh no, the menu. Well, here's the freak out part. Not really that much. Add our menu bar into the GUI. This set menu bar to this menu bar. This menu bar is this menu bar. Menu bar right up here. So we're using this a lot in terms of this component. This set menu bar is this menu bar. This menu bar add. What are we going to add? This file. This file is this file, which is the file menu. So when we're going to run it, we really only have one. So what are you going to do? You can take this code for the assignment number 3, and instead of this one here, you can add one next to it. The one next to it is going to be called style. What are you going to be doing? You're going to be changing the font. What did I just do in this example? I made things big. What's your style going to do? It's going to change the text style of the text that appears in the text box. Font, color. It's easy. Foreground color, background color, font style, font family, font. It's, trust me, it's easy. I'm practically giving you the assignment. It's easy. But I made the font bigger. The other example had a mono font set. Remember the one I gave you, the first one I gave you, that was the calculator? Is that a mono font? I think it was called. I'm not sure what it's called. But here's the problem. Is I said I made the text bigger, right? And I'm going to save it. And I'll save it. I should set this to open up to the desktop, which I can do, and I'll show you in a few minutes. It opens up to, I'm setting it where to open. And set it to big one so I can see it. But it's going to look small because it's just in the view. Look, I made I made things big. No, you didn't. It's pretty small. It's just the text view that's showing it that way. You don't have to make it bigger in the file. Just make it bigger in the text view. Just do what I just did. I made the font bigger. But you're going to have a menu that says Style. Select Font. Select the size of the font. That stuff is actually easier because you have choosers for that too. There's a chooser component. Let me show you the chooser component that we're using for the file. Where did this test come from? I have multiple of these opened up already. So let's go back here. So let's see what we did here. Where was I? Notepad, Notepad, Notepad. So we set the file, set the label to file. So first off, we designed the menu pretty simple. Now we need to add a couple items to populate it later on. You're going to do that on your own. So now it's time to work with the menu. So we only added a file menu, but you can add more. So I'm going to start working with the menu item content here. So we need to add the open option. So we're going to add the save option and the close option. So open, save, close. Set label to open. So open this .open file. What was open file? We have these created up here. We have open file, save file, and close file, which are all menu items. So we have the menu. We're going to create the menu items and then add them to the menu. So add the action listener, this one. Set the shortcut. What is this going to be like? You know how you see like Option or Control O, Control F, shortcut keyboard keys that allow you to use the menu, just in case you don't have a mouse handy. You know, everyone has a mouse handy, so kind of obsolete. We could take that out, but it says the keyboard shortcut. So same thing for the save, same thing for the close. Don't have to go through it 3 times. I hope you got the impression. We're just basically setting the title, setting the action listener, setting the shortcut, and then file.add. If we forget to add it, we haven't added it because the menu is called File, and we have set this menu to load here, menu bar, add this file. File.set label to file. File, add this .open file. Add this .save file. Add this .close.
So we can go to any level.
Yeah. So we're adding, we can do them in different orders too. We added it, but we didn't add the components to it. We added the file to the menu bar, but we never added the menu items to the file menu that we added to the menu bar. So we did the menu bar first, we did the menu next, and we did the menu items third, and we added them in reverse order. It doesn't matter how you add it. So you can take the menu bar, create it, take the menu items, create it, create the menu bar, add the menu. As long as you add them all together, like they all get added, nested correctly, you can wait and do what we did, do it last. We added the menu items to the file menu, after we added the file menu to the menu bar. She sells. I'm not going to do that, I can't. It sounds like a tongue twister because it's all called menu, but all right, last but not least, the brains of the operation, the action performed method. The action performed method is going to be e.getSource. Well, what's the source? Well, it's going to be either this close, this open, or save further down the road here, this save. So depending upon which one we get, we're going to do something slightly different. What are we going to do for the open? We're going to do a file chooser. JFileChooser open is equal to new JFileChooser. You know that big old GUI that came up that looks so sophisticated? You've spent a lot of time building that GUI. Here it is right here. One line of code, and it builds the GUI for you. What we have to do is open a file, so we have to figure out which file was selected. So integer option is going to be open.show open dialog, this, for which one we're going to open from the JFileChooser. If JFileChooser approve option, which means we selected on something, and we have the option, we actually selected on a file and we didn't select on a directory or something like that, then we can actually open it. We're going to set the text area to empty, clear it out, and then we're going to do a try and a catch, and we're going to open it up. So scanner, this is just regular old Java file, IO. Scanner, scan is equal to new scanner, scan it. Scanner is a reader class, didn't look at Scanner yet, but you can actually use Scanner for a file for input from the user. You can enter create a new instance of the Scanner object to get user input. You can do it for all sorts of different things. File reader, open, get selected file, get path. This is all going to come, these methods are all going to come from the file chooser option that we created. And then we're going to set the text area dot append to the scanner dot next line plus a line return. So we're appending it with what we're reading from the scanner object that we created. I'm going to go through scanner. I don't think I've done that yet. I believe it is in file IO that's coming up actually. That's a file IO. That's non-swing related. That's file IO. Reading, opening files, loading files, saving files. And then we're going to throw an exception. We're going to hit exception handling tomorrow as well. Exception handling is going to be brought up here to, hey, we caught a problem, and we're going to catch the exception EX, and we're going to print out the get message that we're going to get from the exception. Hey, file not found, or file not openable. This should open anything, actually. It should open up a binary file, actually. You'll just read it like text. Believe it or not, the code for the save and the code for the close is going to be pretty similar. The decision we have to do is we're going to do a save on the close. Where is the close? It's right here. This dot dispose. Dispose all resources and close the application.
So it will just
It's not going to save anything. Yeah, we're not saving anything. We're just disposing it. Get rid of it. So it's kind of, if you don't save it, you're not gonna. We could modify this, put a little. Would you like to save the file? And then take them to the save menu when the save button is clicked. Kind of easy actually, but we're not that courteous. Instead, we're just going to close it. We're doing exactly what it says. It says close. This dot dispose actually gets rid of the entire GUI. Garbage collects it all, or sends it to the garbage collector to be garbage collected. And that was the open. The last one is the save, and then what we're going to do is a buffer writer out. I'm going to go through scanner and buffer readers and formatted buffer, non-buffered IO. All that IO stuff is tomorrow. So, in fact, I believe it is the lecture I skipped before I got to this one, which makes sense actually. Out.write this text area.get text. So it's getting the text from it. Out.close the file. Throw an exception. That's it. It's pretty easy, no?
But too much.
For a notepad problem?
No, I mean there are so many. How do you remember all this stuff? They are easy, but
nobody remembers it. You kind of go, well, what do I need a file chooser? If you remember file chooser, you can do all the file I/O through the file chooser. If you remember scanner or buffer reader, you can read and write the files. Do you remember? If you can remember Hello World, you can remember the JFrame. Nobody remembers any of this stuff. You have to actually go through and kind of build it by research and trial and error as you're going through it. But if you can remember the hierarchy, and that all these things need to be added, if you walk away with the impression that there's a hierarchy to this, and you have to add a button, you have to add a component to a panel, the panel gets added to a frame, and that you can have to put an action listener on it, and then you have to do an action performed method implementation because it's an interface, then you're going to remember it. I mean, actually, believe it or not, after you've written your first or second notepad program, it's like playing a musical instrument or something. You go, how do I remember this stuff? But all of a sudden, it'll come back. It's like, how do you program, like these guys are doing it, Objective-C and Java simultaneously. How do you remember Objective-C versus Java?
With a compilation.
You sit down, compilation error. No, it takes me a few minutes. I have to look at the Java code, talk about Java, and then all of a sudden I start thinking in Java, and then you start thinking in Objective-C, or thinking in C++, or thinking in Python. It's like a foreign language, actually. Then you start thinking about it, and you go, well, that's how I remember it. But one of the things that might actually help, and you'll find that this is actually good, is exposure to it. The first time you've played with it, the first time you've Googled anything and you've read about it a little bit, all of a sudden you start remembering stuff. Yeah, I Googled that. I can't do that. I have to do it this way. Which is how in the iOS you sort of learn a little bit. Learn about the strings, you learn about, you know, oh, this is how this thing has to happen. That's what that at symbol is at everything. And then after a while, I'd say about, you know, you really have to work with it about 6 months down the road, 3 months down the road, depends on your learning curve. You'll question it, how in the world do I remember this stuff? But you'll look at it and go, oh, that's Java code. And oh yeah, that's how you do it. That's what this is doing, kind of thing. So. Alright, so we have, here, let me end this video. That's everything I ever wanted to know about the first half of Swing. So we still have half of a lecture to go through to finish. We're only on slide number 3 of 13. So, and I have another notepad example, not quite as easy to look at. So we'll do that tomorrow. And let me stop this video. So we're